Imagine you're sick, but you never feel it. There's no fever, no pain, no symptoms. Instead, tiny robots inside your body detect the problem before it begins. They target a single cell, fix it, and move on, without you ever knowing something went wrong. This isn't science fiction anymore. In 2025, we are closer than ever to making this a reality. These tiny machines are called nanobots, and they could change medicine forever. Nanobots are microscopic devices, thousands of times smaller than the width of a human hair. They're designed to travel through your bloodstream, find problems like cancer, clogged arteries, or infections, and treat them directly at the source. They don't just deliver drugs, they could become the drug. Right now, most medical treatments are blunt tools. Pills affect the whole body, even when only one small part is sick. Chemotherapy, for example, kills both healthy and cancerous cells. But a nanobot can go straight to the tumor, deliver treatment precisely, and leave everything else untouched. So, how does this actually work? Most nanobots are built from materials like gold, silica, or specialized polymers. Some are designed to carry medicine inside a molecular shell. Others are built with tiny arms or surfaces that interact with cells. The latest models use magnetic fields, ultrasound, or chemical gradients to move. In some designs, scientists are experimenting with powering nanobots using glucose from your blood, literally feeding them the same fuel your body uses. In early 2025, researchers in Bengaluru, India, developed a method to control individual nanobots inside a swarm. Until now, we could move nanobots as a group like pushing a cloud. But controlling a single one? That's new, and it opens the door to surgical precision on a cellular level. At the University of Saskatchewan, scientists are working on optimizing how nanobots navigate inside the bloodstream. The human body is chaotic. Blood flow is fast, turbulent, and full of obstacles. But if we can steer nanobots effectively, we could send them to one single cell among billions. One of the most promising uses is in cancer treatment. Tumors often grow in hard-to-reach places. Nanobots can be guided to the site using external magnets, deliver chemo drugs only where needed, and reduce side effects to almost zero. In animal trials, this approach has already shown success. Other applications include targeting blood clots before they cause strokes or heart attacks. Imagine a swarm of nanobots identifying a clot forming in your brain, then breaking it down safely, long before you would notice a symptom. And what about diagnostics? Future nanobots won't just fix problems, they'll monitor everything, constantly. Your cholesterol, blood sugar, hormone levels, cancer markers, inflammatory signals. When something changes, you get a notification on your phone. Hey, your cortisol is high, maybe get some rest. It's like having a lab test running 24/7 inside your body, in real time. But with that power comes massive risks. First, there's immune response. Your body doesn't like foreign objects. Even if nanobots are coated with biocompatible materials, your immune system might attack them. Researchers are developing coatings that mimic your own cells, but we're still testing that in controlled environments. In the real world, reactions might be unpredictable. Second, privacy. These devices will generate enormous amounts of data. Who owns it? Your doctor? Your health insurance provider? The manufacturer? In the wrong hands, your health status could be sold, analyzed, or manipulated. Third, hacking. It sounds ridiculous until it isn't. What happens if someone hijacks a system that controls medical nanobots? Could they be weaponized? Disabled? Used for surveillance? These are not paranoid questions. They are real concerns in every lab working on this tech. Then comes the issue of access. At first, nanobot therapies will be expensive. Very expensive. Only the ultra-rich will afford them. That means we'll see a new form of medical inequality, where some people are monitored and repaired in real time, while others still wait days for a doctor's appointment. This could be the biggest divide in healthcare history. But if costs drop, as they usually do with new technology, nanomedicine could become universal. Imagine a future where you never visit a hospital unless something catastrophic happens. Your body is maintained like a machine, constantly monitored, constantly fine-tuned. Medicine won't be reactive anymore. It will be predictive, preventive, automated. Estimates vary, but the first clinical nanobot therapies could be approved within 10 years. Mass availability? Probably 20 to 30 years from now. But the direction is clear. We're not treating symptoms, we're treating data. If we get it right, we could eliminate millions of deaths caused by late diagnoses. Cancer, heart disease, even neurodegenerative disorders could be caught at the molecular level. But if we get it wrong, we could create a world where health is no longer a human right, but a product you subscribe to. So the question is no longer if nanobots will enter our bodies. The question is when And who will control them? The future of medicine isn't in hospitals. It's already being built, molecule by molecule, inside the bloodstream. Subscribe our channel for more videos.